EC is the altitude, not to be confused with attitude, which is something all three of my daughters have. Just kidding, except I'm not. Altitude. The measure of angle 1, u, is 2x plus 7, and the measure of angle 2, u, is 3x plus 13. Find the measure of angle 1 and the measure of angle 2. All right. What is an altitude? An altitude is a fancy word for height. Now, if you're going to measure the height of anything, it has to be straight up and down. So since EC is the height of this triangle right here, EC has to be straight up and down. And since this is a right angle, of course that implies this is a right angle, which implies that the measure of angle 1 plus the measure of angle 2 are 90 degrees when added together. They're complementary. So that's how we're going to set this up. We're going to say the measure of angle 1 plus the measure of angle 2 equals 90. So 2x plus 7 plus 3x plus 13 equals 90. All right, we'll combine that 2x and that 3x because they are like terms, becomes 5x. Another nice round number, 7 and 13 make 20. And that equals 90. Now it's a two-step equation. Subtract 20, 5x equals 70. All right, now it's a one-step equation. Divide both sides by 5, and you get 14. Done, right? Wrong. We're supposed to find the measure of angle 1, not just x. And we know that the measure of angle 1 is 2x plus 7. So the measure of angle 1 is going to be 2 times 14 plus 7. 2 times 14 is 28. And 28 plus 7 is 35. So the measure of angle 1 is 35 degrees. So let me write that out a little bit cleaner. The measure of angle 1 is 35 degrees. Now the measure of angle 2 is done very similarly. Okay, up here measure of angle 2 is 3x plus 13, so it's going to be 2 times not 2. Now the measure of angle 2 is going to be done very similarly. The measure of angle 2, according to the top up here, is 3x plus 13. But you know what? We know x is 14, just like it was up there in blue. I don't know why I didn't just write it down. I wasn't thinking, I guess. So 3 times 14 plus 13. 3 times 14 is 42. 42 plus 13 is 55 degrees. So the measure of angle 2 is 55 degrees. These are my two answers, and this makes sense. If I were to add these guys together, 55 plus 35, I get 90 degrees, which is what 1 plus 2 is supposed to be. All right? So that's altitudes for you. Fun, fun, fun. Find the coordinates of the orthocenter of a triangle with vertices 0, 6, 4, 6, and 1, 3. I know what you're thinking. Orthocenter, isn't that where I go to get my braces tightened? No, that's the point where the three altitudes of a triangle intersect. So let's draw a kind of nice picture of what we're dealing with here. We have points at 0, 6, 0, 6. We have another point at 4, 6, so 4, 6. And we have a point of 1, 3, so estimating, ballparking at 1, 3. All right, so there is a picture, there is a triangle, and my job is to find out where my altitudes intersect. Now, let's be smart here. When you're finding out where lines intersect, you're solving a system of equations, okay? We only need 2 lines. We only need 2 altitudes. So I'm going to make life easy and only find 2 equations of my altitudes. Now let's start with the easy one, which is going to be that guy right there. Remember, my altitude is a line that goes through a vertex and is perpendicular to the side that's opposite of that vertex. So in order to find the equation of this red line, and I'll call it red, In order to find the equation of this red line, I need a line that's perpendicular, okay? So it's perpendicular to 0, 6 and 4, 6, and it has to go through 1, 3. Okay? There. Now, what do we see? Well, if it goes through 0, 6 and 4, 6, it's horizontal, which means something perpendicular to it is going to be vertical. And the equation of a vertical line is x equals a number. Well, what number is it going to be? Well, if it goes through 1, 3, then it's going to go through my x value, which is 1. So great, I already have one of my equations already. I hope finding another equation is just as friendly. No, not at all. I could pick any altitude I want. Let's pick U. So we're going to call it purple because of colors. And if you're colorblind, then it's gray. We need one that's perpendicular to these 2 points right here. So perpendicular to 0, 6 again, and perpendicular to 1, 3 this time. This one is going to go through the point 4, 6. So I need to come up with a slope perpendicular to a line connecting these 2 points. So in order for me to do that, I have to find the slope of that. So remember, you find the slope by doing 3 minus 6, the y values, 3 minus 6 over 1 minus 0. 3 minus 6 is negative 3, 1 minus 0 is 1, so we have negative 3. Now that is the slope of this line right here, which looks right, looks pretty accurate, but so the slope that I want is perpendicular to negative 3. So something that's perpendicular to negative 3 is going to be the opposite reciprocal of negative 3, which means we take that 3, we make it 1/3, and make the opposite of negative, which is positive. So the slope that I want is 1/3. So if I use point slope form, which I'm going to do, y minus y sub 1 equals m times the quantity x minus x sub 1, I can come up with the equation of a line with a slope of 1/3 and now goes through the point 4, 6. So I'll label you x sub 1, y sub 1. You're my m. Let's plug it all in. Y minus 6 equals 1/3 times the quantity x minus 4. Now, before you're all like, all right, well, let's distribute and add 6. No need. This is an equation, and that's good enough for me. Now, what I'm doing is I'm solving a system of equations where my 2 equations are this guy boxed in here and this guy boxed in here. My x value is already solved for, so life is not that bad right now. And what I can do is I can rewrite this equation and just simply substitute 1 for x. So y minus 6 equals 1/3, 1 minus 4. Y minus 6 equals 1/3 times negative 3, because 1 minus 4 is negative 3. Y minus 6, 1/3 times negative 3 is negative 1. Add 6 to both sides, and y is 7. Nope, y is 5. I was going to say 7 wouldn't make sense. That would fall out here. 5 seems to be a whole lot nicer. So since x is 1 and y is 5, that tells me that my orthocenter, the point where all of my altitudes intersect, is going to be the point 1, 5. So this problem on a frustrating difficulty scale was up there towards the 10. Not impossible. I mean, fortunately, this was horizontal. If it wasn't, then maybe we would go up to a scale of 10 out of 10. But I'll give it a 9, just like me. A solid 9. Find the coordinates of the circumcenter of ABC with vertices A, 0, 3, B, 0, -1, and C, 6, -1. Well, let's just pretend that we have a nice little triangle here. So I'm going to draw the triangle. And there's two ways that you could describe what a circumcenter is. If and I'm not, as you can see by my drawing, I ain't good at this. If I were to try to draw a circle connecting these three dots, the circumcenter would be the complete center of a circle. Better yet, the circumcenter is also where my three perpendicular bisectors intersect. Now, a perpendicular bisector is you take a side, like this guy right here, you find the midpoint, which appears to be U, and you make a line perpendicular to it, going that way. You do it again. Find the midpoint, which appears to be U, and make a line perpendicular to it, which goes that way. And then we have these two lines intersecting at a point right there. Now, I know my answer. Okay? I know my answer. It's 3, 1. There it is. Done. But what I'm going to do is I'm going to go through the whole process anyway, because in all honesty, this is a very friendly triangle. It's very friendly. It's graphable. I gave you a graph. It's done. I don't have to think too much, but they're not always going to be this easy. So what I need to do is I need to come up with, so I'm just going to go through the motions, knowing my answer already, knowing what's going to happen. What I need to do is I need to find the equation for this blue line right here, and I need to find the equation for this red line right here. Find out where those two lines intersect. It'll be 3, 1, and when I'm done, I'm done. So let's go through the motions, okay? Blue. I need the midpoint of these 2 points, which is 0, 3 and 0, -1. So I need the midpoint of 0, 3 and 0, -1. And it has to be perpendicular to that as well. It has to be perpendicular to that as well. That's the equation that I need to come up with. The midpoint of 0, 3 and 0, -1 is the average of the x values. So the midpoint is the average of the x values, and the average of 0 and 0 is 0 plus 0 divided by 2, which is 0. And the average of my y values is 3 plus -1, 2. Divide that by 2, 1. My midpoint is 0, 1. Now, to find the slope, I could see it right here. But let me find the slope. The slope is going to be -1 minus 3 because I'm using the slope formula. So -1 minus 3 is -4 over 0 minus 0, which is undefined. So what I need is something perpendicular to that, and something that's perpendicular to a vertical line has a slope of 0. So y equals a slope of 0x plus b, which means my y-intercept, and my y-intercept is 1. So the equation of this guy is y equals 1. All right, so again, I went through the motions to show you how this is done. I'm not going to do that again. Okay, the equation of my red line here is a vertical line, and it goes through 3. So a vertical line is in the form x equals, going through 3 is 3. So now I have my two equations. Where does the equation y equals, or x equals 3 and y equals 1 intersect? How about at 3, 1? Just like I said it would. All right, so these problems have a tendency to get more complicated than this, but there you have it. And again, if you can just imagine that circle being drawn right here, that dot right there is the center. That's what circumcenter means. The perpendicular bisectors of ABC intersect at point G are shown in blue. All right, so you're a perpendicular bisector, you're a perpendicular bisector, you're a perpendicular bisector. Wait a minute. Which means you right here would be a circumcenter. Now, if you don't know what that means, right, if I were to draw a triangle and attempt to draw a circle around it. Okay, the perpendicular bisectors all meet at this circumcenter. Now, why is this important? Well, if my circle is going to hit all three vertices, then the distance from that vertex to the circumcenter is the radius, which means all three of these guys are the same, which means all three of my red lines here are the same, which means if AG is 9, BG is 9. P is the circumcenter of XYZ. PX is 4x plus 3, so where's PX? Your PX. And PZ is 6x minus 11, find PY. Okay. So if this is the circumcenter, right, try to imagine that I drew a circle connecting these three dots. Now, there's no way I'd be able to fit this circle on this page or this slide or whatever you want to call it. The circle would look something like this. P is the center of that circle. So if P is the center of this invisible circle, that means P goes to X, P goes to Y, P goes to Z. All of those are a radius of the circle, which means all of these red lines are the same. So PX is the same as PZ. So if PX is the same as PZ, then 4x plus 3 is equal to 6x minus 11. Now I have an equation with variables on both sides of the equal sign. Minus 4x minus 4x. U become 3 equals 2x minus 11. Add 11, U become 14 equals 2x. Divide by 2, x equals 7. Circle my answer? No. It's telling me to find PY. I'm not given any information about PY. None. But you know what I am given information about? PX. I'm also given information about PZ. So if I just find out PX or PZ, find out what that is, I get PY. So let's do PX because the numbers look friendlier. PX is going to equal 4 times x. X is now 7, so 4 times 7 plus 3, which is 28 plus 3, which is 31. And if PX is 31, PY is going to be 31. That's my guy. Triangle RST is shown below. XU is negative 4y plus 20. XW is 6y plus 10. So XU is this guy. Oh my gosh, that guy right there. And XW is 6y plus 10. XW is, where are you? There you are. There you is. Find the radius of the inscribed circle. Okay, well, this is actually going to be nice. An inscribed circle is created by connecting the dots that are created by these lines right here. So if you were to try, and I'm going to be so bad at this, but I'm going to try my best to draw a circle connecting these three dots. Now that is an inscribed circle. It's a circle drawn inside of a triangle. The nice thing is this line, UX, or XU rather, and XW, they're all a radius of this circle, which means they're all equal. So XU is equal to XW. So negative 4y plus 20 XU is going to equal 6x or 6y plus 10. And now I have an equation with variables on both sides of the equal sign. Add 4y, add 4y, cross u out, 20 equals 4x, 4y, and 6y. I'm so used to doing x. Pardon me. Okay, minus 10. Let me get out my calculator. 20 minus 10 is 10. 10 equals 10y. Divide both sides by 10. Divide both sides by 10. Y equals 1. Circle it. I'm done, right? No. Remember, each one of these guys is considered a radius of the inscribed circle. So all I have to do is pick one of these and plug in 1 for y. So let's pick xw because it seems friendlier. xw equals 6 times 1 plus 10. 6 times 1 is 6, and 6 plus 10 is 16. So for this guy, the radius of an inscribed circle is 16 units, whatever those units are. Okay? Inscribed circle, you're a radius, you're a radius, you're a radius. That's it. Done. In the figure, UV is a perpendicular bisector. So you're UV, you're a perpendicular bisector. It doesn't really look like it, but it is. Of SW, I see it. And VW, Volkswagen, Billy Madison, is an angle bisector. Oh, VW is right here, is an angle bisector of SWT. Find X and Y. So the picture is pretty much drawn accurately. Now it's just a matter of finding out what X and Y are. So let's start with the X's because it's there in alphabetical order. If you are a perpendicular bisector, that means you and you are exactly the same. And by you, I don't mean you. I mean this line segment and this line segment are exactly the same. So let's set it up. 3x plus 1 equals x plus 3. I have an equation with variables on both sides of the equal sign, so let's subtract x, let's subtract x. That gets me 2x plus 1 equals 3. Subtract 1 from both sides. 2x equals 2. Divide by 2. Divide by 2. X equals 1. That's one of my guys right there. Now I need to find y. Y, it lives here and it lives here. Well, which one should I use? Let's use the fact that I have 4y, which is that symbol right there, that angle right there. You're a perpendicular bisector, which means you're 90 degrees, you're 50 degrees, and you're 4y. So I could say 90 plus 50 plus 4y equals 180 degrees from the interior angle sum of a triangle. Combine like terms, I'm giving you 140 plus 4y equals 180. Subtract 140 from both sides. 4y equals 40. Divide both sides by 4. Y equals 10. Now, I could use this information to answer a bunch of questions. I could be like, what's US? And US would be like, okay, well, X is 1, so US is 3 times 1 plus 4. It's 4, which means UW is also 4, which means SW is 4 plus 4, which is 8. I could ask you, find this angle then. And you would be like, all right, well, this angle is 40 minus Y. 40 minus 10 is 30. I could ask you what this angle is, and you would be like, well, you're 90 degrees, and if you're 30 and you're 90, then you're going to be 60. I could ask you all sorts of questions based off of this information. I could say, like, well, all right, well, this angle is 4 times 10, which is 40, which means this angle is 40, and that's 90. So you're 50, which means you're 50, which means I could just go on forever. Not forever, but for like 5 more minutes, asking you questions about this. All I had to do was find X and Y. I gave you some bonus. You're welcome.